start talking about inorganic nomenclature, and this is even more important than organic nomenclature. Hate to scare you, but if you do not get this, then the rest of your chemistry career becomes a little bit miserable because you really need to know the formulas, how to write these compounds so that you can calculate masses and do things like that from this point forward. So with nomenclature, first example I have here is just some common names. I think we've talked about these. You know water, ammonia, you know is NH3. Well, we're going to be talking about things that are not common names. We're going to look at some different ways to write some stuff. So we're still going to break it down into covalent and ionic. So the first thing on your paper, it doesn't list it this way, but maybe even break it down and say A. That's the first thing we're looking at, where it says naming nonmetal/nonmetal compounds. Well, that's what covalent compounds are, is they're nonmetal that are bonded together. And another way to phrase these are molecular compounds. So you should know both of those terms. And a couple things, this is not written on your paper, but a couple things that we want to think about is that if we're looking at nonmetals, think about where those guys are located on your periodic table. Also remember there's different ways to number these groups. This is according to the 1 through 18, but your nonmetals are going to be over on the right-hand side to the right of the stair-step line. We're not talking about ions. Those are not there. So in other words, you won't be thinking about charges. Instead, we're going to look at something known as prefixes. And the prefixes that we're going to be using, you've got to have these memorized. And do make a note that these are different than organic. So for your organic prefixes, you learn things like methyl, ethyl, propyl, butyl. You learn some of those. These are a little bit more common, what you're probably more used to. And then also with covalent compounds, we're typically talking about binary compounds. So what that means is you're just talking about two elements. Both of those elements are nonmetals, but it's just two elements that are bonded together. So it makes it really easy, which really, let's go ahead and even write this on our paper. These guys are easy. The only reason people miss these is because you learn this really, really easy method, and then you learn something a little bit tougher with ionic, and people go back and try and make these tougher than they are. So don't be that person. Okay, our steps are, first we're going to just name the first element. I'm just going to write it out. And then you're going to use a prefix along with that to specify how many of those atoms are present. The only caveat here is that if it's just one, then you omit mono for that first element. You don't use that term. And then for the second element, you do the same thing with your prefixes, but you change the ending to "ide." It just sounds better. You'll notice that as you go through writing these. So the first one, Cl2, sounds like dichlorine. Notice I did not change the ending on that one because that's my first element. And then I've got 7 oxygens, so it's going to be heptoxide. Now the other unwritten rule here is that I know my prefix is hepta, but because I have 2 vowels back to back and hepta is more than just one syllable, I chop off that A, so it just becomes heptoxide. Okay, next one you guys all know is carbon dioxide. Yes, I have 2 vowels back to back, but this is just one syllable, so you just keep that dioxide. And notice this is a case where we omitted mono because it's that first element. We did not say monocarbon. Okay, next one is carbon monoxide, not monooxide, just monoxide. And then sulfur trioxide. Easy, easy. So now if we work in the other direction, diphosphorus, sounds like we have 2 of those phosphorus atoms, and pentoxide, O5. Nitrogen dioxide is NO2. Silicon tetrachloride is SiCl4. And chlorine trifluoride, ClF3. And notice you just write everything the way you see it. You don't do any reducing. This is also a good point to go ahead and make note again about our diatomics that we've learned. So you should have these memorized, and the way you remember them is I bring clay for our new house. And if you look at where they're at on the periodic table, it makes it that much easier to remember because you always have a periodic table in front of you. Now, the only reason you ever have to think about this is if I ask, hey, what's the formula for oxygen? You would say, well, it's O2. But if we're looking at something like this and it's dichlorine heptoxide or carbon monoxide, I don't have to worry about oxygen being diatomic because, hey, he's hanging out with carbon, so he's not by himself. So it's only when that element is just by itself and it's not bonded with something else that you have to worry about it being diatomic. That takes us to ionic. And with ionic compounds, this is where I would say part B. With ionic compounds, we're talking about metals and nonmetals. But keep in mind, we're talking about metal and nonmetal ions. So go ahead and put a positive and a negative there, remembering that metals lose electrons, giving them a positive charge. Nonmetals gain electrons, giving them a negative charge. So here, we're talking about things forming ions. They form ions here. So part one, that's what we're going to do today. Part one is naming ionic compounds whose elements have a single charge. In this case, if you look at your periodic table, and you should have picked one of those up today as well, for you to just scribble notes all over, and we've got some polyatomic ions listed on the back. So for these, single charge, in other words, group 1, these guys right here, your alkali metals, always, always, always have a +1 charge. Alkaline earth metals, +2. Your group 3, but we're still talking about metals, group 3, which is the metals, in other words, underneath that stair-step line, these guys are going to have a +3 all along there, so that you just have to memorize. As far as the anions, in other words, group 5, 6, and 7, we know that group 7, your halogens are all going to be a -1. Chalcogens are all -2. And then again, this is where we get that stair-step line in there. And for these guys, we're going to say that definitely nitrogen and phosphorus, I would really even throw possibly arsenic into this, that these guys are going to be a -3 charge. So those you are memorizing, they have that one and only charge to them. And then we go back to our cations, and we left out a whole bunch of them. We left out all of these guys in here. Your transition metals, actually I guess I should just go to there. And then we've got a couple in here that we left out. So we're going to address those more tomorrow. But what we do see from this is that there are a couple that we still have to have memorized. And you have these written on your sheet. That your silver, zinc, and cadmium all have one definite charge. And the way you can remember this, if you remember, you look on your periodic table and you see that aluminum is +3, just go down diagonally, +2, +1. Well, if zinc's +2, cadmium's also +2. So these guys you just have to have memorized. And this is what you're seeing on your notes. Okay, so this is not on your notes, but just a little reminder, thought about what we just said. If you saw something that said F-1, that is fluoride, calcium ion, aluminum ion. I'm going to come over here. Nitride, bromide. This, if it was S-2, that would be sulfide. But here it's just S, so that's sulfur. It's not an ion, it's just an atom of sulfur. And then something else to note, and you'll see this on your homework, is that hydrogen can either act like a metal, having a positive charge, or a nonmetal. So if it's just a metal, but +1, it would be hydrogen ion. Whereas here, we have hydride. So that's how you would write those. And then the way we want to go ahead and use these ions in names of ionic compounds is we're going to follow these rules. That you simply name the metal first, and then you name the nonmetal. So it makes it really, really easy. You just name the metal first, then the nonmetal, and again, you change that ending to "ide." So first thing maybe you want to make note of, on your paper, let's see how I can write this. I'll write it right here. On your paper, you see that left-hand column. Notice how those are different than the guys on the right. Make yourself a note that those are all binary. In other words, they're just two elements, silver and chlorine, sodium and sulfur, calcium and iodine. Whereas here, on the right-hand side, they're not binary, but they are ternary. And what that means is that you have a polyatomic ion in there. So maybe you need to remind yourself what a polyatomic ion is. Poly means more than one, and it's polyatomic, so more than one atom bonded together with a charge. That's what makes it an ion. So the first example we're going to do, remember all we're doing is naming our metal and then our non-metal, and for our binaries we're just going to change the ending to "ide." So Ag, silver. Cl, no, that's chlorine, but it becomes chloride. Na, sodium. S, sulfur, that becomes sulfide. So maybe right about now you're going, well, wait a minute, what does that have to do with anything? That's okay, we're going to talk about that on the back side of the notes, but really what that comes down to is that this is the one and only way to write that. You will never be given NaS2 or NaS or Na3S. This is the only one that you would ever be given, and you would be asked to name that because that's the one and only way to write that compound, which will make more sense after we go in the reverse direction. Okay, next we have CaI2, which is calcium iodide. That's it. Notice all of those endings have that "ide" ending. Okay, then we come over here. The tough part about this is that you guys have not had much practice with your polyatomic ion sheet yet. So you would have to flip that over. It's on the back of your periodic table. And you would flip that over. And we know this, that's easy, potassium. But you look at this part right here and you notice that that is not just a single non-metal that you're naming and changing the ending to "ide. Instead, you would search and search and search and search and search, and you would find that PO4 is phosphate. Eventually, maybe even by the time you start your homework, you'll get a little bit more practiced with this, and you'll be able to say, wait a minute, I see this 3 here. I know this is a +1, so that must mean this is a -3. It's okay if you have no clue what I'm talking about right now, but this will make more sense later. So you would then be able to at least narrow it down and look at your polyatomic ion sheet and look under the -3s for this. So PO4 is phosphate with a -3 charge. Okay, next one, Ba, barium. And you're looking for this, OH. Yeah, you happen to have 2 of them. Notice that there are no parentheses on your polyatomic ion sheet, so you're looking for the OH. You just have 2 of them. As you come across that, it has a -1 charge. It's hydroxide, barium hydroxide. Then we get to aluminum and SO4. Yeah, you happen to have 3 of them. But you're looking for it, and you find SO4 under your -2 charge, and it is sulfate, aluminum sulfate. Okay, so that made sense enough. Let's work in the opposite direction now. I'll start tying together here. So when ionic compounds form, they do so making the opposite charges equal and add up to 0. This is really the key of the whole thing, is that really we just want to form neutral compounds. You want your number of positives and negatives to be equal so that you get that 0 charge on there. So the rules that we've got are to write down the formula for each species in the compound. So you write that formula down, the symbol. Then you look and see how many of each positive and negatives you need to make them add up to 0. I don't really like the way this is phrased because I think it leaves out some information about writing down the charges, but I'll show you as we go through these. And then the last thing is to put those amounts as subscripts, because those are just telling you the number of atoms you need of each. First example, sodium. Well, we know sodium, and this is how I want you to write this. I want you to write sodium's symbol is Na. Then, up on top of the word, I want you to write the charge. This is where your scratch work goes. Not, I'm going to go ahead and box this in. This area is where I'm going to write my formula. That's my answer. So I should never have charges written there because the compounds themselves do not have charges written. They're just neutral. So I'm going to write my scratch work on top of the words. Sodium is Na with a +1 charge. Chloride is Cl with a -1 charge. So in order to make this electrically neutral, you should be able to look at that and say, yeah, that's it. You just need one of each. So we're good. Next one, magnesium bromide. Magnesium is Mg. You look at your periodic table and you see it has a +2 charge. Bromide is Br. Again, you look at your periodic table and see it has a -1 charge. So in order to make this electrically neutral, +2 -1, you would say that your least common multiple is 2. So you need to get it to be a +2 and a -2. +2, we're already there. -2, that means you need 2 of your bromides in order to do that. Potassium nitride. Potassium is K, has a +1 charge. Nitride, that comes from nitrogen, is N with a -3 charge. In order to get them electrically neutral, I need a +3 and a -3. So to get a +3, I need 3 of my potassiums and 1 of my nitrogens. So that's it. Notice with all of those, again, we see that "ide" ending. So that made it really easy. All we had to do was look at our periodic table, and we know that those are all binary. You just have a metal and you have a non-metal from your periodic table. But on this side now, we see endings in "ate." It could have easily been an ending in "ite," something like that, but that's not from our periodic table. That's going to be from the polyatomic ion sheet. So to go through these, you do the same sort of thing. You say zinc, well, that's going to be Zn. One of those that you memorized has a +2 charge. Phosphate. This might take a little while to look up, but you look and look and look, and you find phosphate is PO4, and it has a -3 charge. So in order to make this electrically neutral, your least common multiple is going to be 6. So you need a +6 and a -6. In order to get a +6, you should be looking at that and saying you need 3. To get a -6, you need 2 phosphates. You think that's right? There's something wrong about that, and hopefully you're saying yes, we need parentheses, because otherwise it looks like you have 42 oxygens and 1 phosphorus. So you need to throw in parentheses to show that you have 2 phosphate ions. Okay. The other thing about this that you'll probably catch on to as you go through these, notice that really all we did was we took this without the charge, just the number, and we crisscrossed it. In every single one of these situations, I can come over here, the way we wrote those formulas was we crisscrossed. And that's okay to do as long as you realize that there might be times that you have to go through a reducing process. So I'll show another example of that later on. But really the best way to think about this is making a neutral compound. Always have that be in your brain. Okay, silver sulfate. Silver we know is Ag, has a +1. Sulfate, you look that up. SO4 has a -2 in order to make this electrically neutral. And that's it. Last one. Cadmium is Cd, has a +2. Nitrate is NO3, has a -1. So you need to have 2 of your nitrates. So that's how you'd write it. Okay, let's point out a couple things. As far as your polyatomic ions go, most of the time, if you see "-ide", you know it's coming from the periodic table. But occasionally there will be an "-ide" ending that comes from a polyatomic ion. The most common one is hydroxide. Get used to that. That's OH with a -1 charge. And there are some others as well. So look at your polyatomic ion sheet and you should be able to distinguish among those. And they're not similar to any of those other elements that are on the periodic table. The other thing I want to point out is that ammonium is not on your periodic table. There is no AM, and every year I get somebody that tries to write AM as a symbol for ammonium, and it's not. It's ammonia that has, remember ammonia is NH3? Well, it's gained an extra hydrogen ion, so it becomes NH4 with a +1. And the only reason I'm bringing this up is because this is one of our few positive polyatomics. In other words, it's one of the few cations for your polyatomics. And so it's pretty common also, and we use that quite a bit. And the other thing I want to mention, and I kind of alluded to this earlier with some of the monatomic ions, is that if I asked for the formula or how you would write chloride, chloride is Cl with a -1 charge. But that's different than if you were asked to write chlorine, because chlorine is Cl, and then you think to yourself, ooh, it's diatomic, so 2. So just keep those things in mind. Those little tiny changes in letters make a big difference. Which brings me to the very last thing I wanted to mention. And let's do these two first. If we had strontium oxide and strontium hydroxide, well, we know strontium is +2, oxide is -2. And this is just pointing out that if you try to do that crisscross that we talked about, you're going to get yourself into trouble if you just say SR2O2. Instead, look at that and think about making it neutral. Well, it's +2 -2. It is neutral, so that's it. That's your formula right there. And then strontium hydroxide, it's a +2. Hydroxide is OH, which is a -2. If you were to then just say, I'm sorry, what did I just do? It's a -1. If you were to just go ahead and crisscross or whatever it is, think about it being neutral, and you put a 2 there, that would be wrong as well. You have to have 2 hydroxides, not just 2 hydrogen ions, but 2 oxygens as well. So even in that situation, you do need parentheses. Okay, these, I just wanted to mention how one tiny little letter, itty bitty little letter, really makes a big difference in how you write these things. So calcium +2, nitride comes from the periodic table, is -3, so it becomes that. Calcium +2, nitrite from your polyatomic ion sheet becomes that. So again, that's just one letter that we're changing, but it's a really completely different compound. And then we can change one more, and what we end up seeing is that. One of the things that you'll notice as you get some practice with these is that the only difference between 8s and ites is that your 8s have one more oxygen than your ites do. So you have now just finished your first day of non-organic nomenclature.